my lab is interested in two areas of biotechnology that overlap in tissue engineering. One is our classical approach to biomaterials, where we're using different materials with different fabrication to get to our end goal, which is to create new clinical treatments. I'm trained as a dentist and a clinician, and also as a PhD. So my focus has been trying to be practical about these sophisticated systems that we are building, so that we are not spending 10 to 15 years through regulatory hoops to get to a real product. The other part of my lab works with biophotonics. And we have, in our research, uncovered a direct target for near-infrared light that is responsible. It's a growth factor that can be activated. And we've been using that technique to selectively evoke spatiotemporal growth factor actions within these scaffold systems. And that is the two parts that have come together in this talk. The major advantage of using this approach, and there are other approaches that have tried to do temporal control. So most of the spatial control within material systems usually rely on the ability of the material to degrade in a controlled manner, releasing its payload. And that gives you some amount of temporal control, but it's dialed in as you make the system. The other approach in this area has been actuation with different biophysical modalities, including ultrasound, radio frequency, and light. And we are in that area of interest. So not only can we rely on material to release certain cues, but by using light, we add a temporal component, thus making it much more clinically viable. A limitation to this is trying to translate this into a practical clinical delivery system. So the fact that you can place a material directly on a wound or any kind of clinical situation, it makes it easier with the material component. The complication has been, how do we get light into that material system through normal tissue or other materials? For example, one of the main systems that we talk about in this presentation is a dressing for healing your pulp inside your tooth. So a practical aspect of that is not only can we dial in material cues that come out over time, but we can actuate it over time with light. But usually, if you place such a medication, you will also put another filling on top, either a metal filling or a plastic composite filling. So that has provided a bit of a barrier because you need to go through that material without changing its own material properties. So that's been a bit of a limitation. And we've been designing different systems to overcome that.